Statistics Lesson 8.4, Testing a Claim About a Standard Deviation or Variance. The objectives are, develop the ability to use sample data to conduct a formal hypothesis test of a claim about a population standard deviation or variance. Here are the components that should be included in the hypothesis test. Statement of the null and alternate hypothesis expressed in symbolic form, value of the test statistic, selection of the sampling distribution to be used for the hypothesis test, identification of a p-value and or critical values, statement of a conclusion rejecting the null hypothesis or failing to reject the null hypothesis, statement of a final conclusion that uses simple and non-technical terms to address the original claim. Testing claims about standard deviation or variance. Objective, conduct a hypothesis test of a claim about standard deviation or variance. Notation. So N is going to be the sample size. S is the sample standard deviation. S squared is the variance, sample variance. Sigma is the population standard deviation. And sigma squared is the population variance. Requirements. The sample is a simple random sample. Number two, the population has a normal distribution. This is going to be much tighter with the chi-square or doing this than it has been in the other. Test statistic, chi-square equals n minus 1 times s squared divided by sigma squared. P-values, table A4 with degrees of freedom equals n minus 1. Critical values, use table A4 with degrees of freedom equals n minus 1. Equivalent methods. When testing claims about the standard deviation or the variance, the p-value method, the critical value method, and the confidence interval method are all equivalent in the sense that they will always lead to the same conclusion. Properties of the chi-squared distribution. All values of chi-square are non-negative and the distribution is not symmetric. There is a different chi-square distribution for each number of degrees of freedom. The critical values are found in table A4 using degrees of freedom n minus 1. Critical note. In table A4, each critical value of chi-square in the body of the table corresponds to an area given in the top row of the table, and each area in that top row is a cumulative area to the right of the critical value. With the z-table, it started from the left and worked to the right. With chi-square, it starts to the right and works to the left. Example. Listed below are heights in centimeters for the simple random sample of female supermodels Lima, Bunchen, Ambrosia, Ebanks, Inman, Ribic, Kirkova, Kerr, Crows, Swanepoel, Prinsloo, Hosk, Kloss, Robinson, Heatherton, and Raffaelli. Use a 0.01 significance level to test the claim that supermodels have heights with a standard deviation that is less than sigma equals 7.5 centimeters for the population of women. Does it appear that the heights of supermodels vary less than the heights of women from the population? And here we've got some heights. So we have some numbers here, some heights of these women. And I went ahead and put them in the calculator here. So what we're going to do is we're going to go menu, 411, number of list is, and we want super, and there we go. All right, so we got that. Now let's go back to our data here. We've got that. Let's follow the process. And let me get some room to write on. I don't actually need that now that I got those in there. So number one, it said sigma was less than 7.5 centimeters. And in step two, then sigma is greater than or equal to 7.5 centimeters. 3, our null hypothesis, it will be 7.5, let's see, sigma equals 7.5 centimeters. And our alternate hypothesis will be sigma is less than 7.5 centimeters. And that's the original claim. All right. Step 4, our alpha is 0.01. And in step 5, what test are we going to use? We're going to use chi-square. All right, so let's see here. Chi-square, and that is going to be n minus 1 times s squared, the sample standard deviation squared, divided by the population standard deviation squared. Okay, now I went and calculated that stuff, so let's see here. We got 1.843908889. All right, so let's see, this is going to be 16 minus 1 times 1.8439. 1, and then that's going to be squared over 7.5 centimeters squared. Let's put that in our calculator. So let's go here and control divide, and we have, I'm just going to put 15 times, that's 16 minus 1, and then I've got 1.83844391, that ought to be close enough, squared over 7.5 squared, and that's going to give me 0.90668, and I'm going to go with 0.907. I'm going to round it to 0.907. So that's going to equal 0.907. All right. 6. We need to calculate our p-value. So let's calculate what's our p-value? P-value. What's our p-value? Let's go in here, and we're going to go menu, 6, 5, 8. So our lower bound, since we're going from the left, our lower bound will be 0, tab, and then our upper bound is going to be 0.907. And our degrees of freedom is 15. And, okay, so that is definitely less than 0.01. Okay, so that is p-value is less than 0.001, which is going to be less than 0.01. So 7, we will reject the null hypothesis. The chi-squared 0.907 falls in the critical region. So 8, we conclude that there is sufficient evidence to support the claim that supermodels have heights with a standard deviation that is less than 7.5 centimeters for the population of women. All right, so that's how we do it with the p-value method. And let's do the critical value methods. Same numbers as before, okay? So 1, sigma is less than 7.5 centimeters. 2, and sigma greater than or equal to 7.5 centimeters. So our null hypothesis would be sigma equals 7.5 centimeters. And our alternate hypothesis, which is the same as the original claim, is it's less than 7.5 centimeters. 4, our alpha is still 0.01. And 5, we're going to use the chi-square test. And that's going to be n minus 1 times s squared over sigma squared, which will be 16 minus 1 times, and I'm going to use 1.84391 over, and that's going to be 7.5 squared. And again, we'll still get 0.907 rounded. That's rounded. Rounded. All right. Now here's where it's going to get a little bit different. Okay, for critical, here we have chi squared equals 0.907. Now we have to find our critical value 2 ways. One, we can go to our table And since we're doing a left-handed test, and remember it starts from the right and works its way back, we're going to find 15 is 5 degrees of freedom is 15, and 1 minus 0.001 is 0.99, and that's going to give us 5.229. Okay, so our critical value is 5.229. And you can see this is definitely less than that. You can also find it in your Inspire. Let's go to our Inspire. We're going to do menu 659. Our area is going to be 0.01. Our degrees of freedom is 15. And we get 5.229. Okay, works both ways. So again, we're going to reject the null hypothesis. And let me draw that. Let me draw this. It's going to look, and then you've got something like this, and it goes like this, and then it never actually touches. It keeps on kind of going there. Gets kind of closer. 5.5, we'll say this is 5.229. So that would be, this is our critical region in here. And we're over here at close to here. Put that red. We're over here at 0.907, which is definitely in the critical range. Okay, so let's go back up here again, same as before.
May I have your attention, please? The department chair meeting that was scheduled for today at 2.
Sorry for that public service announcement. Is the same as before on the previous slide. We conclude that there is sufficient evidence to support the claim that supermodels have heights with a standard deviation that is less than 7.5 centimeters for the population of women. All right. And then now let's do the confidence interval method. I don't know what the problems were. Again, we're going to use the same data. 1 through 5 will actually be the same. Okay? Let's see. 1, the original claim is less than 7.5 centimeters. 2, then sigma is greater than or equal to 7.5 centimeters. So our null hypothesis will be sigma equals 7.5 centimeters. And our alternate hypothesis will be sigma is less than 7.5 centimeters. Again, this will make it a left tail test. 4, we have our alpha equals 0.01. And then 5, I'm going to write it up here. I'm going to write 5 right here. This is going to be a little bit different. We're going to use chi, I didn't draw it right. Chi squared left is less than sigma is less than chi squared right. Okay? And so that's going to look like the square root of n minus 1 s squared times s squared over chi squared left, or excuse me, right. This, I did this backwards. For this one here, it's right, and then that's left. Okay, so that's going to be right. is less than sigma is less than n minus 1 s squared over chi squared left. Okay. So now we're going to have the square root of 16 minus 1, 16 minus 1 times, and we're going to use 1.84391 squared over 30.578 is less than sigma, and then we're going to have 16 minus 1 times 1.84391 squared over 5.229. Well, how did I get 30.578? Let's go back. All right, we got 5.229. So remember, that's the left one. To find the right one, and we can go over here. Let's go to our table. 15. That's 0.99. Well, if you go down here, if you follow across here to 0.01, you get 30.578. That's how I found it on the table. If you go to your calculator, we did this one right here and got 5. If we menu and then 6, 5, and 9, area 0.99, degrees of freedom is 15. We get 30.5779 or 30.578. So that's how I got those. That's menu 6, 5, 9. Okay? So there we go. And let's calculate those. So control square root, control divide, and we're going to open parentheses 16 minus 1 times, and then open parentheses 1.84391 close parentheses squared over 30.578, 30.578, and we get 1.29146. So we got 1.29 is less than sigma, and then let's go up here and we'll grab that, and we'll come down here and we'll change that to 5.229. 5.229. Oh, darn you. I may have just go up here and grab that. And then we'll go in here. 5.229. It usually works pretty good for me. 3.123. So we got this less than 3.123, I believe it was. Yeah. All right. That's 3.12. We'll just leave it there. All right. 7.5 does not fall in there. 7.5 does not fall in there. So again, we will reject the null hypothesis. 6, 7, reject the null hypothesis because 7.5 does not fall inside the confidence interval. And then 8 will write our statement like we did before. We conclude that there is sufficient evidence to support the claim that supermodels have heights with a standard deviation that is less than 7.5 for the population of women. And again, that's whoop, there it is right there. And that would be our statement. Okay, 3 different ways, same result. Good job, folks. I will see you in class tomorrow, and have a wonderful evening.